Hello everyone, in this video we will learn how to solve the box Willow from TryHackMe. So first of all, you have to connect to the VPN and once that is done, I will go to this place where I have a few things from this box because I have already solved it anyways. Alright, so the first thing you would want to do whenever you see your box is check if any any website is hosted on that IP address. So when we do that, we get a long list of characters and we can see that this is hexadecimal character, so it's a really long character. If we go to the source code, we don't see anything at all. If we reload the page, we don't see anything at all, so let's leave it be. So then what we have to do is nmap scsvpn and the IP address and save it to a file called nmap, and I have already saved this output. So this is the output of nmap. We can see that SSH is open, HTTP is open, and 111 is open, and whenever 111 is open, NFS is also open. So we can see we can see if we can mount anything using this command, right? So the IP address was 10.201.69 and 15, and we see that /var/failsafe is available to mount. So now what we are going to do, we are going to mount. First of all, we are going to create a directory called target NFS, and I have already done that, as you can see right here. And then we are going to be using this command right here. I don't know it by heart, so I had copied it. Sudo mount -tnfs, and in the IP address we are going to be pasting this IP address /target nfs, which means mount this from the IP address into our target nfs folder and -o no lock, and I have already done that as well. And after that we will be able to access. Okay, so maybe I have to do that again. So sudo mount -t nfs, IP address is to / and then mount this in target nfs, mount this in the current directory because we are in target nfs already, and that's -o no lock, and I have a really long password. This should work. So this did not work. Does this work? So I mean, there we go. So we have mounted into this target NFS folder, and now we can go inside var and then failsafe, and then we have this file called RSA keys, which is an ASCII text, CSV ASCII text, and if we print this, we get public key pair and private key pair. Now public key and private key pair for what? We just saw a bunch of hexadecimal codes right here, right? So maybe let's first cyber chef. Let's first go to this website called cyber chef, gchq.github.io/cyberchef, and let's see if we can decode this hexadecimal value. So we have to write hex and drag and drop this from hex and paste the entire thing here, and here we see we've got an output. Let me try to zoom in, and it says, hey Willow, here's your SSH private key, you know where the decryption key is, right? So this is our SSH private key, which has been encoded letter by letter, character by character, using this public key right here. So what we have to do is we have to decode this using this private key. So if you know how RSA key works, or how public key cryptography works, for instance, right? So right here, so this picture right here, it's taking, okay, so here we can see that the plain text is being encrypted by public key and is going to be decrypted by the private key, right? So I actually wrote a code. Of course it was not perfect in the first try, I had to correct it somewhat, and this code is decrypt.py, right? So I made a variable called encrypted and pasted the entire decrypted hex value here. Then we have n equals to 37627, so n is the public key that we got, right? And we have d equals to 61527, so this was in the private key. So this is for decryption. We had another value there called 22 or 23, which would have been E, but we don't need that for because we are not encrypting, we are decrypting, and we are going to be storing the result in this variable right here. So for I in encrypted.split, so it means that it's going to treat each of these characters, it's going to iterate through each of these characters one at a time, and decrypted dc equals to power int I d n. So this is basically the formula of how RSA is decrypted. You can go and Google it. It's basically, the result is same as I power n and then modulus, sorry, I power d and then modulus n. I believe this is the formula, right? So this is basically the formula for decryption, and we are going to be adding each of that decrypted result into our result variable, and we are going to print it. So when we do this, when we run this program, we get this. So begin RSA private key, and we will then store this in a file called IDRSA, right? So and then we have to chmod plus 6, sorry, chmod 600 id underscore RSA, and then SSH-I id underscore RSA willow at the rate this IP address to access this to access the terminal using SSH. However, this will not work because as we can see, this is encrypted, right? So first we have to find the password for this SSH key. Now what we can do is we can use ssh2john.py or simply ssh2john. Now if you are using Kali Linux or Parrot, or your John the Reaper is well configured already, simply writing ssh2.zone would do the job, but since mine is not, I have to write the full path, which is user share zone run and then ssh2zone.py and then id underscore rsa, and we're going to be saving this in a file called hash. Now when we run this, we can see that the hash is created now, and now we can, again I have to write the whole path, user share zone run zone and then hash, and word list equals to user share word lists rock u.txt. Now I have already run this, right? So when you run this, you will get the answer, or you will get the passphrase for accessing the terminal, and that would be, okay, maybe I have to do it again, but let's not reveal the password. You guys do it yourself. I already showed you. It's basically zone hash and the word list is rocku.txt, right? And now what we have to do is ssh-i id underscore rsa willow @ this IP address right here, and yes, and it will ask us for the passphrase for the key id rsa. We will enter the passphrase and it will tell us sign and send pub key, no mutual signature supported. So what we have to do here is, it basically means that it's not supporting the SSH RSA, so we have to add that ourselves. So pub key accepted algorithm equals to plus SSH-RSA, and now we have to press enter. And now when we, yes, so now we are in, we have finally accessed this, right? So in the home folder of Willow, we see that there is a user.jpg, and if we bring this user.jpg over to our terminal, which I have already done, I use SCP for this. You can also simply create a http.server using Python and then get it using http is to / the IP address is to 8000 / user.jpg. There are many ways of transferring. Anyways, so when we open this user.jpg file, the first flag, we get the first flag, so this is the user flag, right? And now so now, sorry guys, I had someone called me, so I had to go. Anyways, so now the first step while privilege escalation is always sudo tackl, and we can see that /bin /mount and /dev all of this can be accessed by the user Willow without having the need for the root password, right? So let's see what this dev contains, because we know what mount means, right? So dev contains a lot of files and a lot of shares. Actually, it contains a lot of shares, and one share that it contains that will intrigue us the most is this. The share that will intrigue us the most is this hidden backup. So what we have to do is, we will create a random folder in the home of Willow, and then we have to mount -t nfs dot slash, okay, I forgot. So all we have to do is sudo mount slash dev slash hidden backup into our random folder, and if we go to random folder now, we will get the creds.txt. if we print it, we get the password for root and willow. Now if we privilege escalate to root using this password, and if we cat slash root.txt, it says that it has already given us the flag some time ago. Now the flag that it gave us is this picture right here. So what we have to do here is stagid extract -sf user.jpg, and the passphrase is this willow password right here. Okay, the passphrase is this roots password right here, and if we see, this is the root flag. Thank you for watching.